Okay, so in this final video we're going to be looking at using multiple models and using guardrails. Now I've switched to the a slightly more developed version of the project. This is called Drug Prediction V2, and this model is actually it's in the GitHub repo, so it's here. So if you wanted to import this into your own instance of ADS, if you clone this repository then down to your local system, zip this directory up, then you should be able to import that as a top level item here. So if I was doing this here, click on this import button and you see how it wants a zip file. So what you need to do is zip up this folder and then import it into a top level decision solution. With that said, it should look pretty familiar to the one that we've been building live. So I have a drug selector decision service. And just like in the one that I was building live, you can see I'm taking in the gender, blood pressure, etc., and then converting that into a patient data object. But now I come into this decision node which is called model selection. And if I look at the logic in model selection, you can see that there's a number of different rules. And notice here we've got this first rule applies. So whichever one of these rules applies first, this is the decision from this node. And you can see that the first rule checks for males under 50 years old and then sets the decision, which is actually the shorthand for the model that we're going to use, to P6. Similarly, females over 90, they will use rules. So again, this is code to say to a subsequent decision node, don't even use a predictive model. The confidence is going to be too low. We're going to use a prescriptive model, which is actually defined in another decision project. But our default is to use the P3 model. So this is a default rule that executes at the end if nothing else has been decided. So we come out of this model selection with this that model selection variable being defined, and it's called, it'll be called model selection. So when we come into the execute model node, which is still quite similar to the one we had in the previous project, this one now has access to two different predictive models, which we can see from these dotted lines, or it can also use the rule-based selection. So just because it has access to these predictive models doesn't mean that it uses them. This is that dotted line. It doesn't have to use it. So if we look at the logic inside here, we will see again the rules are applied in sequence. But first off, it's going to check to see if the model selection is rules, and if that's the case, then it will set the decision to the rules-based selection computed from the patient. So what it's going to do essentially is go off to here and use another decision project that has some conventional business rules that will determine a drug based on some characteristics. And again, that was reserved for people who are over 90. It has another rule that will check to see if it's supposed to be using the P6 model, and so if it finds P6 in this model selection variable, then it's going to use this P6. This is actually a decision tree. But the final rule that it will check, which is essentially the default value, is that if the value is set to P3, it's going to use one of those XGB models over in Watson ML. Now after that, we can see that the result is flowing into this final drug type node along with a decision on whether or not the data was valid. And so in here, again, first rule applies. We will see that if the data is invalid, then we will set the decision to be invalid data. There will actually be no drug recommendation made. Next rule to check will be to use the model results if the probability from the model is more than 95%. Again, the final rule is if we have a low confidence from any of our models, is that we're going to say no advice is possible. So I'm not going to code these up live. Again, you have the building blocks for this in the videos that we've done previously. This is just a more refined or more expanded version of that with more models and an actual external rule service. You'll remember when we were adding the predictive models, we used this little icon here to add a prediction. But this one here, this kind of this turquoise one, that actually adds an external decision service. We can take a quick look at that here. So this is the rules-based selection. It's a very simple decision service. It takes in the patient details and makes a drug selection. In fact, there's very little logic at all. So if all the following conditions are true, the age of the patient is more than 95 and it's female, then we will set the prediction. Otherwise, the infamous malaria drug. So back up to the other model, and we'll run some tests. Okay, so there's a few tests that have been defined. We've got a test for low confidence, one for P3, one for P6, and a rules-based test. So we'll start with the low confidence. No, let's start with the P3 test. I guess it's essentially the default. We can see that this is the data that was passed in and then turned into the patient details. The data was considered valid. The P3 model was selected. We can see that we've got a prediction of drug E with a 99% confidence, and this is the final output, which is reflected up here. We can try another model. We'll get a very similar result. This is the decision tree based model that was selected for certain parts of the patient population. And again, we can see valid data. P6 was selected, and we've got a very high probability. This is typical of the decision tree, always returns a probability of 1. And again, we've got the output of E. This one, you can see we've got a 92-year-old female. Remember the model selection rule. This will identify patients in this category and say, look, we're not going to be able to make a confident prediction out of either of the predictive models. Use the prescriptive model. And we can see here's the data. It was considered valid. Model selection was rules, and we've got our malaria drug recommendation for some reason. And the final one is where we have a low confidence. So in this instance, again, it was considered true. We decided to use rules, but we picked a drug with very low confidence. So when we've come up to the drug type rule, we can see that the drug type node, the rule that's been triggered is actually the low confidence rule. And we can see that the output of that was no advice possible. Okay, so that wraps up the video. We've seen multiple models and some guardrails applied to interpret and reason upon the results that we're getting from a variety of models.